This video is binomial distributions part 3. So we're picking up with the last slide we did in the last video, and we had found all of these probabilities using this probability distribution on the left. Now to find all of those probabilities, if you'll recall, we had to do a lot of scratch work on scratch paper to find all these probabilities. This doesn't even show all the work that we did. This is only the work we did for the last one. The other ones, they took a lot of effort, and they took a good bit of time. So the question is that the amount of time we're always going to have to spend? And I think I discussed in the last video how if we have the hamburger problem and we bring 10 people to Whataburger and they each buy a hamburger, what's the probability that, let's say, 3 of them will win the hamburger? And there were all sorts of scenarios. The probability of 3 winning the hamburger, the first, the second, and the third person could win, or the second, the third, and the fourth person could win, or the third, the fourth, and the fifth person could win, or the first, the fifth, and the 10th could win. And there's so many scenarios, it would take us all day to figure out the probabilities by hand. So we can shorten the process by using a formula, a table, or a calculator. So this is the formula. It looks a little complicated. We haven't learned this right here, so we're not going to use this formula. Okay, we're not going to use it. We're not going to learn it. Another way to do this is to use a table to find certain probabilities, and you would need to know the number of trials and the probability of a success to find the probability of certain random variables. So what's the probability that the random variable is 2, given that the number of trials is 3 and a probability of a success is 0.15. So you'd go under n and you'd find the number of trials, which is 3. Then you go over to k. K is our x. In this case it's 2. And then you're going to follow along to the right until you get to the probability of a success, which was 0.15. And the probability would be 0.0574. But if we had something like this, what's the probability that x is less than or equal to 1? So we would need to add together the probabilities of 0 and 1, because the numbers that are less than or equal to 1 are 0 and 1, so you would add these two together. If it was a probability of x is greater than 2, you would add the probabilities of 2 and 3 together. But you could see how this could get a little bit tedious depending on what the probability was asking and how many trials there were. So we're not going to use the table either. Our preferred version is going to be using the calculator. Alright, so to find binomial probabilities with your calculator, there's 2 functions that we use. One is called binom PDF, and the other is called binom CDF. Binom PDF and binom CDF. And you can find these by pressing second vars. So on the calculator, you press second vars, and you will have a menu of items, and you will scroll down until you get binom PDF, which is A on this screenshot, or binom PDF, which is B on here as well. Now you need to check your calculator. For some of you it might be 0 and A. To get there quicker, once you figure out which letters correspond with binom PDF and binom CDF, you could hit second vars, and you could hit the alpha button and then A, and then it's going to take you straight to the binom PDF function. Now let's talk about what each of those functions mean. First, let's start with binom PDF. Okay, binom, think binomial distribution. PDF, think probability distribution function. So we use binom PDF when you're trying to find the probability for an exact number of successes in a binomial experiment. So we only use this when we have a binomial experiment that passes those 4 characteristics. Those check off. There's a fixed number of trials. There's 2 outcomes of success and failure. The probability for a success is the same for all trials, and the trials are independent of one another. And if that's the case, we can use binom PDF to find the probability of an exact number of successes. Now you need to know 3 things to put into your calculator. You need to know the number of trials, which we call N. You need to know a probability of a success, which in an earlier video on an earlier slide we call P. And we need to know the exact number of successes that we're trying to find the probability of, and that would be X. Now, for those that have the newer 84s, when you choose binom PDF, what's going to happen is it's going to give you prompts. So you can see trials, that would be N, your number of trials, and you would type that in. P is your probability of a success. Make sure you put this in as a decimal. You could also put it in as a fraction, which it will convert to a decimal, but don't put it in as a percent. And then you put in your X value. You would choose paste and then hit enter. However, if you've got a TI-83 calculator and it doesn't have the prompts, and there's a possibility that some of the older 84s don't have prompts, you would hit second vars, choose binom PDF, and then parentheses will pop up, or left parentheses will pop up, and you will type in N, the number of trials, whatever that number is, followed by a comma. The comma is found right above the number pad. Next you will type in P, the probability of success, comma again, and then X, and close the parentheses. Now these are the same numbers in the same order that the people with prompts will be typing in. It's just you will need to remember what needs to be typed in because you will not be prompted. So this would be a good thing to go on a note card. Definitely write it in your notes. When you do binom PDF, you need to know that you need to type in an N, comma, P, comma, X. And those would be numbers, not the actual letters. You're going to actually type in the numbers that represent those for each probability question that you're going to do. What I want to do next is I want to go back some slides to the coin problem that we did, and we took so long to do that, and I want to do this with the calculator. Alright, let me pull up our calculator here. Alright, so if you remember, we had a bias coin that had a probability of 0.6 of being heads, and the coins flipped 3 times. X is the number of heads, and we created a probability distribution, and it took the better part of one of these videos. So to do this with the calculator, we're going to use the binom PDF function because we want to know the probability of exactly 0 heads, exactly 1 head, exactly 2 heads, and exactly 3 heads. So to find the probability of exactly 0 heads, we do seconds vars. Vars is right here next to the clear button, so it's towards the right side. Now you can scroll up until you get to binom PDF. Make sure you choose PDF, not CDF. There is a difference. Now mine asks me for trials. I'm going to put in how many flips that we're doing. We're doing 3 flips. And then the probability of a success for a heads is 0.6. So that's convenient. I already have that in there. And the X value is 0. And then I go to paste and hit enter. Now notice right here you can see the end of the word binom PDF, parentheses, 3, 0.6, 0. This is what those without prompts would type in. Now I'm going to hit enter, and look, we get 0.064. So let's do this again for exactly one head. Second vars binom PDF. There's still 3 trials. The probability is still 0.6, but this time the x value is 1. And we get 0.288. Same thing, just much quicker. Now let's do the probability of exactly 2 heads. Second vars. I want to show you another way to get there instead of scrolling. You need to make sure you know which number it is. Now mine is A, so if it was a number I would just type the corresponding number, but since it's a letter I'm going to hit alpha, and then you see the little A right here below it, above the math key. I'm going to hit math and see how it takes me straight there. Now trials are still 3, probability is still 0.6, x value is now 2. Probability is 0.432, same thing we got. One more, probability of exactly 3 heads, second vars, binom PDF, change the x to 3, and there we go. We get 0.216. So that was much quicker. I want to show you one more thing. Now we made this on a table. You can actually make this whole table in the calculator. What you do is you go to your stat and I've cleared my list out and I moved to L1, and what you want to do in L1 is you want to type in all your random variables. So there were 3 trials, so always start with 0 because there can always be 0 successes. 0 successes, 1 success, 2 success, or 3 successes, because there's 0. You can get 0 heads, 1 head, 2 heads, or 3 heads. Now, rather than typing in the probabilities, we want the calculator to calculate all these probabilities for us, even though we know what they are now. But pretending we didn't, we would like the calculator to calculate it for us. So what you're going to do is you're going to highlight L2. Notice that I moved the arrow up so that now L2 has a black box around it. Make sure you do that first. So now, since I wanted to find the binomial probability for each of these over here, we're going to choose second vars and then choose binom PDF and hit enter. And it's still 3 trials. Probability is still 0.6, but for the x value, we don't want one number. We want all of the numbers, so that basically the column's going to do a formula, and the formula is going to be filled in the whole down the whole column. So we want all of the x values, and where are the x values? I just typed them into L1. So just type second 1 for L1. And now what it's going to do is it's going to substitute each of those x's in one at a time and get the corresponding probabilities. So I'm going to hit paste. If you had the 83, you type it in with parentheses like this, 3, comma, 0.6, comma, L1, close, and then hit enter. And look, it populates the same probabilities that were on our table. So that's just a little shortcut for you. Okay, we're going to stop this video and we'll pick up with the next portion in the next video.